So let's go ahead and take a look at electrical charge. The first thing to remember about this is something that you guys probably learned years ago, that opposites attract. So it's not just a saying for romantic relationships or anything like that. It actually came about because of electrical charge. We've got two different types of charges. You've got a positive charge and a negative charge. And as the saying says, if you've got a positive charge and you've got a negative charge, they'll actually attract each other. Think about if you've got kind of magnets on the table. You'll learn that magnets and electrical charges have a lot of things in common. And one of those things is that opposites attract. So if you put a positively charged object next to a negatively charged object, they'll actually go towards each other. And if you put a negatively charged object next to next to another negatively charged object, they'll repel each other. And that's kind of the first thing that you should realize about electrical charges is those opposites attract. Same charged objects will repel each other. Another important thing to remember is that charge is quantized. So basically you've got electrons and you've got protons. And when two objects come together, if they've got a charge, so if I were to take two charged objects and touch each other, then some of that charge would actually transfer to the other. So if I've got some largely positive charged object over here and a largely negatively charged object over here, if I touch them together, then they'll start sharing those charges, and they'll split it up across from each other. So basically, the object over here has an excess of electrons. The object over here has a deficit of electrons, and when they come together, these electrons that are overcrowded say, hey, I'm going to jump over to this object over here, until they end up splitting evenly amongst each other. So they might come out to be neutral objects, they might not come out to be neutral objects, but when they come together, they split that charge evenly and then separate. So if this one has, let's just say, a positive 5 Coulomb charge, and this one has a negative 5 Coulomb charge, then when they're touched together, this whole system has a total charge of 0 coulombs, which at the end they will split that between each other. So each of these objects will have 0 coulombs at the end. So let's go ahead and get into a more difficult practice problem, because obviously if you touch the same objects next to each other, then they will come out to be 0. So let's take a look at this problem right next to right here, and we'll see if you guys can figure it out. Take a moment to read it. Go ahead and pause the video. Alright, so if you did read it, we've got three separate spheres here: sphere A, sphere B, and sphere C. On sphere A, we've got that negative 20, and then NC stands for nanocoulombs. So coulombs is that unit of charge. Over here, we've got 0 coulombs, and over here we have positive 10 nanocoulombs. So this right here is my start. I'm going to call this position 1. And then we come over and they say the first thing that happens is we've got sphere A touching and then being separated from sphere B. So the total together, they have negative 20 nanocoulombs, and when they come together and touch, they'll split that charge between them. So some of these excess electrons will actually jump over to B, because B is currently not very crowded with those electrons. So we'll end up with negative 10 nanocoulombs here and negative 10 nanocoulombs there. Since we didn't do anything with C, C actually stays exactly as he is. So that's the first thing that's happened. I'm going to go ahead and put a little line through there to know, hey, you've done that. Next, sphere B is touched and then separated from sphere C. So in this third situation, A is going to stay totally stationary, not changing at all, but B and C touch. Together, they've got a total charge of 0, which gets evenly split between them, which means that B is going to have a charge of 0 coulombs, and then C will have a charge of 0 coulombs. So there they are, touched and then separated. And last but not least, C is touched and separated from A. So in my final position here, I'm touching A and C. If A has a negative 10 nanocoulombs, and C has 0 coulombs, then their total, they've got negative 10 nanocoulombs between them, which would give me half on A, so negative 5 nanocoulombs. B, nothing happened to it, so it keeps as what it had. and C got the other half of -5 nanocoulombs. And so there we are. We're figuring out what's the final charges on all three spheres. Well, A is at -5 nanocoulombs, B is neutral, so it's at 0 coulombs, and C is at -5 nanocoulombs as well. And that's the basics of how charge is transferred between things. You've got an excess of electrons on one of these, you've got a deficit of electrons, and as you touch them, they'll jump to wherever is easiest for them to go. Because these are metal spheres, they conduct very nicely, and it's very easy for those electrons to move between those objects.